Okay, Happy New Year. This lesson is basically a review lesson. Here we're starting off with a comic. They thought he was weird. 13117532. Happy New Year. So if you haven't figured it out yet, this person, or if you want to figure it out, you can pause it now, but I'll tell you that this person is counting down the prime numbers. Okay, so let's jump to the math ones. So quadratic formula, we know what this is. When completing the square, which is false. C must be on the right, that's true. Add boxes to both sides, that's true. A can be any number, false. A must be reduced down to 1. What is the discriminant? The discriminant is b squared minus 4ac. Explain what it must evaluate to in order for roots to be imaginary. If the roots are imaginary, the discriminant must be negative, because when you take the square root of a negative number, you have to take out the I. If the roots are real, rational, and equal, that means a single answer, it must be 0, because square root of 0 is 0. Real, rational, and unequal, well, they're both going to be positive, but because it's rational, it's a perfect square. And scenario number 4, positive but not a perfect square. When completing the square, how do you determine which number goes inside the boxes? b over 2 squared. What are all the methods of factoring? There they are. And all the methods of solving a quadratic equation? There they are. The quadratic equation here is plugged into the quadratic formula below. Evaluate the roots using a calculator. What I really need you to remember is what chunk to evaluate at a time. Remember, you can't do it all at one time without using all sorts of parentheses. I think it's easier just to evaluate the part under the radical first, giving you 8. If 8 goes under here, we have 4 plus or minus radical 8 all over 2. Let's do the numerator first. 4 plus radical 8, hit enter. Then divide it by 2, giving you this decimal approximation. Then let's do the minus version. 4 minus radical 8, press enter, divide that by 2, we get this answer. So rounded to the nearest hundredth place is 3.41 and 0.59. So today's review will basically be, let's solve this quadratic equation using all the methods we know, and then let's confirm the roots, the nature of the roots, by finding the discriminant. So let's go ahead and do this one first. We have c squared plus 10c equals 5c minus 4. Well, first let's put it in standard form. So we have to subtract 5c from both sides and add 4, giving us c squared plus 5c plus 4 equals 0. So let's solve this by the factoring method. So we need to find out what two numbers multiply to give me 4 that add to 5. That's 1 and 4. So therefore, when we factor this trinomial, we end up with c plus 4 times c plus 1 equals 0. Setting both binomials equal to 0, we end up with c equals negative 4 and c equals negative 1. So our solution set is negative 4 and negative 1. Let's look at completing the square method. Now let's take our standard form equation, and when we complete the square, you must subtract the numbers to the right and keep all the variable terms to the left. And don't forget to add in your boxes. Now, how do we know what number goes in the boxes? b over 2 squared. 5 over 2 squared is 25/4. Some people want to put this in the calculator, which you can do, but I prefer to keep it as a fraction because on the Regents, your multiple choice answers will be in fractional form. So here we have to combine, we have to simplify this. We need a common denominator, multiply by 4 to get a common denominator. Negative 16/4 plus 25/4 is 9/4. So over here, I hope you saw that this step here, this trinomial can be rewritten as a perfect square binomial. And then, of course, you must take the square root of both sides Fortunately, 9 and 4 are both perfect squares. So when you take the radical of 9 and the radical of 4, you end up with 3 halves. Of course, you have the plus and the minus. So when we subtract 5 halves from both sides, we end up with negative 2 halves, negative 8 halves. Reducing each fraction, we end up with negative 1, negative 4, which should look familiar because if you did everything correctly, same answer, different method. Finally, let's use the quadratic formula. So plugging in our coefficients, A is 1, B is 5, C is 4, we end up with this expression. 5 squared is 25, 4 times 4 is 16, bring down the minus sign. 2 times 1 is 2. We keep evaluating, keep simplifying. 25 minus 16 is 9. This works out nicely because we have a perfect square under the radical. Negative 5 plus or minus radical 9 over 2 really becomes negative 5 plus 3 over 2, negative 5 minus 3 over 2. Keep cleaning it up, simplifying. We have negative 2 over 2, negative 8 over 2, which gives me negative 1, and negative 4, which again is consistent with our other methods. Okay, last step, which actually was part 2, I want you to determine the nature of the roots by using the discriminant. Well, the discriminant, like we said before, is b squared minus 4ac. That's the part under the radical in the quadratic formula. Once we plug these in, we end up with 9. If you remember, if your discriminant is positive, it's real. And it's also unequal, has 2 roots. We need to determine whether it's going to be rational or irrational. Now, because 9 is a perfect square, we end up with a rational set of roots. So comparing these properties of our roots, if we actually look at the roots themselves, negative 4, negative 1, yes, it is real, it's rational, they're unequal because there's 2 answers. So that confirms that we have done this correctly. Now, your exit slip is this problem right here. R squared plus 4R equals 2R plus 80. So, just like the previous example, part 1, solve this using factoring. Part 2, determine the nature of roots by using the discriminant. Part 3, find the x-intercepts by completing the square. And part 4, find the zeros using the quadratic formula. Now, I use different words, zeros, x-intercepts, roots. They all mean the same thing. They're all basically the solution of the quadratic equation. So there you go. Good luck to you.